Now, if you look at these modern data intensive workloads, they are clearly pushing boundaries. Are we seeing new stress on the traditional hyperscale model? And if yes, what is driving it? Is it latency, regulatory pressure, scarcity, or the need to move closer to users?
Most definitely, because the cost is a pressure. The hyperscale providers have amazing technology, but the costs are substantial. If you want to make a very accurate model, you need a huge amount of data. And so trying to move that around, especially as you mentioned around scarcity of certain compute or GPU nodes, that might mean you're moving it from hyperscaler A to B or from region A to region B. And that is expensive. The cost of moving these vast data sets to where they need to be to get the most value out of them is a challenge. And making sure that where you're moving to them is sustainable for the longer term, because if you've moved it to region B, you don't really want to do a move to region C and then D and then E and so on. So just from a cost point of view, it can be a challenge. And then you do have latency. If you're trying to move these things around the world, it takes time. It doesn't matter how big the pipes get, it still takes a period of time to actually get it where it needs to be.
And when that strain builds, who feels it the most and who feels it first? The users or the hyperscalers? And how is it affecting performance, cost, and overall reliability on both sides?
So I think it's a multiple set of circumstances that have come together. So yes, it creates an impact on those end users because the ability to retrain that model or give it new data or new access to data takes time, because if you've got new sources, they have to be integrated, they have to be baked into whatever that model happens to be. The other side of that is these models are so incredible, and I'm not trying to be hyperbolic, but they essentially contain all of human knowledge to this point. And that's brilliant at a conceptual level. But if you're trying to build something that can tell you what sneakers are in season this month, and will work with what pair of trousers, do you also need it to be able to calculate the curvature of space-time near the event horizon of a black hole? Now, the chances are probably not. These are quite distinct sets. But because the model contains all of that information, it's had to be processed and churned through and manipulated and whatever else goes to it. So the models and the tokens for those models cost accordingly. Now, if you just want to be able to look at your specific data set and make decisions or interact with users based on that, that can and should be a much more affordable proposition. You couple that with moving it much closer to the users, then you fix that performance challenge, because it does take time to get from California to Scotland, where I am right now. And I'm not going to have as great an experience as someone on the West Coast with whatever chat thing they're interacting with, as I would do if it was here in, say, Edinburgh, which is 20, 30 miles away.